Okay, so we are working on it, right? So I think, yeah, we are right. So yes, we are right. So yesterday we made it possible to parse the actual file and examples C, right? So we took the source code and we transformed it into a list of tokens. So today we will start by checking the list of tokens and parsing it. For now, I want to make a very simple example that just, I don't know, like the hello world example, right? So the minimal example. But first, let me start by creating a new branch. I will call it day2, and now we put everything in there. So I start by doing the hello example. In here, so the simplest example would be something like this. So int, no, not int, sharp pointer args, and from this I can yeah. So even that, just remove this for now and make it let's just parse that function. No arguments and just a body statement. Just that. So let's start by doing that. So let's start by going to main.c and check for some things like after tokenizing we need to create a node. So let's try to create a scaffolding for it. So we have a parser that will parse, right? So it will return a bool, take a parser, and that's pretty much it. So this, so it will return true if everything goes okay. So now it wants a parser. What is a parser? A parser is a struct of a list of nodes and a cursor and tokens. So we can start by creating the tokens that we will copy from the tokenizer, the cursor that we keep track of the current token, and we need nodes. So a node, struct node, so a node requires a type, so node type, and it will be a union thing, then can be, yeah, so it's a union, so union, right? So this union will contain all the types that it can be, and then from the node type we can inference the node that we are going to parse or even use, right? So if the node type is an import statement, we check the import statement and then generate the code for it. So the node type is an enum of node type, and that's it. Yeah, use of it. So nt for node type and fun deco. Just a bit. Back. So now it needs a list of tokens. A list of tokens, we just create nodes struct that contains nodes, a node list of pointers to nodes, so 2 stars in there, int count and int capacity. So now we have also nodes, and the parser is done, right? Yeah, it's done. So you can start by so yeah, if we split in here and go to hello, this statement is a top level statement, so like int a equals 10 and 19 in this case. So this is a top level statement, and this is a scoped statement because it's inside a box statement from the top level statement. So from that we can just start by assuming that the parser just parses top level statements, and then the top level statement parses the rest and contains it itself. So just like mini ASTs. So we can close this one. So in here we can start by saying something like while p dot cursor is less than p dot tokens dot count, we can just something like parse result, so result rest equals parse top parser top top level statement, right? And then we give it the parser. If the result can have something like this, so okay. If it's not okay, we just do something like this, return false, else we append, right? So we use the a append on p nodes, the res nodes. It looks like a good API, right? So for that we need to create it. So type def struct parse result. It contains a boolean, which is okay, and a node pointer that it's the actual thing. Okay, so let's create the function that returns that. So parse results, parse top level statement, p for parser, and that's it. So okay, this is an error because I forgot an s, and this is like this. Okie dokes. So now we need to check if the token that we get is a valid token for a top level statement. So for that, I'm just gonna, this is like how can I say this? So we have some keywords that automatically says that it's a top level statement, but in some cases, like a function, it starts with a type, then a name, then an open paren. That's what's gonna differentiate a global variable from a function declaration, right? So we can start by saying something like get token and pick token. So we can check, yeah, that's it. So we start by saying something like token, in which we do parser get token, this should just return parser get token, no, so parse p tokens items p cursor, something like this, right? So this returns a cursor, the current token at the cursor. We can also do something like token parser get token off, in which it does parser p, this one so it has an offset, right? And then it returns p tokens items p cursor plus offset. This one we need to create a fix me, be sure that the offset is in bounds. So a peak, what can I do now? So we can create a token one also that returns a token one that parser picks at, right? Yeah, get token off also works like a pick. We don't need this one. So let's start by doing that. So yeah, let's start by doing that. So but we also need something that, so I take the token, which is parser get token, and then I switch on the type, right? So token type, if in case of TT ident, then we can say something like default print f invalid top level token. That's it. So we for now just return something like invalid response, and we can create a macro for it. So define invalid response, which is a parse result of false and null. This also returns eval it res, because it should return from inside the switch statement. So here we need to pick at so parser gets token, and we need to pick at the second one, right? So the current one plus 2, right? So pick 2. So this is pick the token offset. So if pick type equals tt open parent, we then do parse result res parse fn parser parse fn tackle statement, which returns that, right? So we can do something like no, we can just return, because it's the same return type. If it isn't, we do else printf evaluate token we can do something like this, evaluate token, we just say token max me when and token max me, and return evaluate res. So let's parse the top level function declaration. So again, it returns a parse result, parser parse fn tackle statement, which takes a parser, and that's it. So what can we do this in here? What can we do in here? So first of all, our node also needs some more information, which is the token walk from the start point and the token location at the end. So we can actually check the source code when we have errors, and since we need one of those things that C has it and I don't want it, which is order of declaration is fucking stupid and I don't want it. So in here I'm just gonna say something like this, node is this, so okie dokes. And this because we need to create a fn declaration deco statement, right? And in here type dev struct fn deco statement. In this one we are going to save the base, and then we can start making things. So fn deco statement, let's just open something here like evnf md. We don't have it, so I don't remember that good about evnf So this is a grammar syntax, so I don't really know how it works, but can try it. So we need an identifier that is just like A to Z, right? Letters A to Z. Then fn decal statement is an identifier, another identifier, a literal open paren, then a list of arguments, which is fn parameter parem, then another literal, which is the close one, and then a block statement, right? That's a function declaration statement. Okay, so a top level statement is fn decal statement for now. For now it's just this. So fn parem is an ident. I don't know if I have to place this, but I don't think so. So this is actually a type expression. So type expression, which actually is a name, so it's an ident, and then can be something like this or this, right? I think it's the only ones that it can be. Yeah, I think that's the only one that it can be for now. This is one or more, so I don't know how I say it, one or more in EBNF, but yeah. So this is actually a type expression. Also, the fn parem is also a type expression. And so what do we need also? We need a block statement. Block statement is just a literal open bracket and a list of statements. Then we can use, right? And the statement is something for now. We don't have anything for now, right? Right. I think that's it. That's it for now. So let's start by going into it. So we need a type expression, but for now I'm just going to put fix me. This should be a type expression, because for now, for keeping things simple, since we just want to pass the first example, I'm going to assume that the type is just a simple type, like int, void, those sort of things. So it's actually just a sharp pointer. Name, type name, and int type name when. Next we want the actual name of the function, so we do the same thing, sharp pointer name and size int, but not this, and name. And we need a list of function parameters that we don't do for now. Yeah, we also don't do for now, so fix me. Add parameters, and then we need the block statement, which is just another block, which is a node pointer, right? Yeah. See, so this should be working for now. So fn tackle statement. So yeah, let me put something like this in here. So I think that we are going to make it work, right? So where is the thing? So we need to start by parsing the name, and by parsing the name we also need something like an expect token, so that it can fail and we can, yeah, so that's it. So we need something like a bool that we can expect. We take the parser and the token type that we are expecting. So in this case we do bool OK equals get parser get token, p type equals tt. If not OK, if return false, right? Not OK, we return false. Else we do parser cursor plus equals 1 and return true, something like this. Right, so let's start it. So first, I need another one. So I need one that returns that bool and does expect and get, right? And then it does parser p token type tt, and then he accepts a token pointer token, right? So in here we say bool okay is we check if the token is the one that we want, similar to get expect token. If not okay, same, we return false. Then we do token. Oh, no one is talking today, so what is happening? Oh yeah, so you only call it T. I do reinforce it and say that it's equal to T, and then I do parser cursor is equals 1 and return true, right? Yeah, so let's do it. So the start one, so this is the type, right? And we do expect token type. So we do if not expect and get p. So the token type is an identifier and the token is type. If not, we just return we say something like def failed to parse type of function declaration. Something like this. I'm sorry, I need to okay, I'm back. I think I'm back. So we return invalid response. Kidokes. Now parse function statement. So we have the token type. Then we need to do the same thing for the name. Name parse function declare type. So name. Just a bit. I'm back again. So so token name. So we have the name, and then we need what? So now we expect. So we expect the tt open paren, right? We printf expected that after we expected this after function name return invalid res. So we do the same for the other paren, because for now we don't have the function argument. So print now. So fix me here. We should parse the function parameters. So now we should have a parse statement, right? So we need to create another function that parses statements. So yeah, so this is something like if So we expect first, we can't expect, because if we expect we are going to broke, so I'm just going to call parse expect. Yeah, so parse result, right? And we say parse result is parser parse statement, and parse statement takes a parser and that's it. If not res okay, we do printf failed to parse block function body, return invalid response. So now we need to create that shit. So parse result, parse statement, parse, and here we just check the token. So token, we do token equals parser get token from p, we switch on token, and we do case tt open curly, something like this. We break. If it's open curly, we do parse result, parse, so result, no, we return it, so return block parser parse block statement and p. Right, we can switch a token because we need to switch on type. Here we return invalid response. Then here we say default is printf failed invalid token. Return invalid res as well. So we need better messages, but for now it's okay. So now we need to parse result, parse block statement, which we parse. Parse. Yeah, so I was thinking about something, yeah. So now we expect if we expect, so we need the start, so start which is this, if expect and get parser tt open curly and start. We printf invalid token start as of block statement. This is kind of useful because we only get here if we parse it open curly, but yeah, return invalid res. Then here we should parse other ones, but yeah, if so, in here we need to create a fix me, actually parse the body, right? So expected get, so this one requires a close query, and then we need to return the node. So this is a parsec of node. And what is it? So we define parsec as a parse result that as true and node, and the node is passed in here. Right. So the node, so a node pointer node equals temp log size of nodes, and then we need to so this requires an end. Right, so we say node start equals start lock, and node end equals start end lock. Yeah. Right, so then we need to create the block statement. We didn't create it yet, right? Yeah. So here we need to type def struct it's just a list of statements of nodes in this case, so it's just node point nodes. It's just this, and it has node as a base. So nodes isn't declared here. Yes, it's here. So can I place it here? Yeah, okay. So he has a base and the list of nodes. So in here, what is it? So I say block statement equals temp block size of node block statement, and then we say statement base is the node, and statement nodes is empty for now. Say nodes this is a pointer. Which then I can say node as equal, so node block equals statement. So that's it, I think. So this is what we need for parsing a block statement. I'm going to call it block statement as well. So what is it? Block statement. So why don't we, what happened here? Assigning block statement. Yeah. So this is my fault. They need to be pointers, not just parse block statement. Yeah, yes, parse block statement. More. Parser statement. This one I created. Yeah, again, so it needs another letter here. Yeah, so now that we have everything, we can create the node as well. So node pointer node equals the block, same size as the other one. So node start equals the type block, node end equals type equals rise node end block, no, just end. So also, yeah, that's it. So then we need a fn decal statement pointer, fn equals temp allocator size of decal statement, the fn base is node, fn name equals, alright, so name type name equals, what does it equal to? It equals to name me, and fn, no, it's not name, it's type. For fuck's sake, I hate C and the fucking arrows to the reference. So base type name, so type name len equals type me len, fn name equals type, so name me, and fn name len equals name me len, fn body equals res node, and then node as equals fn. Right, I think that's it. Then we just return parse success. Return parse suck node. What the fuck you want? It's a block. Yeah, it's a block, not a. So it's a block, right? And as it doesn't exist as is node fn statement or fn decal statement. That's it. So in theory it should just parse everything. Let's see. Yeah, we need to actually call it. So we need to parser parser equals something like this, and we say parser tokens equals tokenizer tokens, and then we just if not parser parse and parser, we do printf failed to parse, return 1, and let's see it. So it failed to parse, invalid token import. Yeah, because we are testing the wrong one. So, and we kinda breaked, right? Right. So let me go into knob and add cmd append and cmd gdb, something like this. Then we can say gf2 main, Then we run with examples evaluation. Exit normally. Why? Okay, that's a new one. If it doesn't parse, it turns failed to parse with 1, right? So we check if cursor is less than p tokens count. We parse the top level statement. Right, so let's start by the printfing stuff. No, so we go here, right? Yes. So then we go here, and do we break an expect and get? No. Oh right, because we succeeded, but then it didn't fail, right? So printf parsed. So yeah, so we succeeded. So let's start by doing something like for int I equals 0, if I is less than parser nodes, parser nodes items count. We do I plus equals 1. So then we can say node, which is node is parser nodes items I, and then we switch on node type. If case, oh, we never set the node type. Yeah, we never set the node type. That's a freaking dog shit thing to do. So node type equals mtfn decal, and then we also need mtfn body block, just a block. And then when we parse the block, which is around here, right, it is the block statement here, we need to set its type as well. So node type equals empty block, because empty fn decal, we can do fn decal statement, but for now we just break. The default, just so the compiler won't, so this one is going to break here. So we take the fn decal statement pointer, statement equals node fn decal statement, right? So now we have information about it, so we can printf fn decal statement, and then we can say something like _4 name, which is something like this, statement name when, and statement name. So we also can take the type as no, just in this one, so as name with type name G, and that's pretty much it, right? That's pretty much it. Let's see. Yes, we returned the fn deco statement that has an int as a type and name as a main. So it's working, right? It's working. Now we need to type check it and generate the code for it, but I think that might be for another day, right? I don't know. It's almost 1 hour. I have other things to do. It's 12 p.m. almost 1 p.m. So yeah, I think I'm just going to do another thing, which is create a printer for it. So we can say like void print node right, and then we can say switch on node type. So let me something like this. This will just say print node, and then we can say something like this, in which then we can say print node, the statement block, which is body, I think, right? Is block. So then we can say case empty block, and we can do something like printf block statement and break here. So we can remove this because we need to take care of them all. So yeah, it's working. It's working. So let's just commit everything. So this is a new example. Example minimal parsable file. This is an EBNF grammar file, grammar. Then this is compile with debug info. Then this we don't care, and this we can just say added parser for a simple, a minimal example. That's it. So we can push everything into version 2. That's it for today. So thanks for tuning by, and I'm going to be back in tomorrow maybe.